This next problem is kind of a fun one to try and draw. It says the angle of elevation from the top of a building to the top of a nearby taller building. So let's just start with two buildings. Okay, so it's building number one. Here's my taller building. Okay, so I've got two buildings. Obviously one's taller than the other. It says a nearby taller building. Okay, so the angle of elevation to the top of the building to the top of the taller building. Let's go straight across. That angle of elevation in there is 48.3 degrees. The angle of depression to the bottom of the taller building, that angle is 18.1 degrees. So if the short building is 61.7 meters high, so this building is 61.7 meters, we want to know the height of the tall building. So we're trying to find this total height. Okay, well, we already know some of the height of the tall building. We know that this is 61.7 meters. Okay, so it seems to me that all we need to be able to find is this height, and then we can add it to 61.7 and we'll have the total height. Well, in order to find this height, this length x, we need more than just one angle of this right triangle. We're going to need a side also. And it's going to be impossible for me to find this hypotenuse right here, but I can find this shared edge of these two right triangles. Throw that in there. So that's what I'm going to try and do first, is I'm going to use this bottom triangle to try and find this edge. Okay. Let me pull that out and just kind of work it separately. So we're looking for this edge here. We can call it a variable. Let's call it y. I could say that the tangent of 18.1 degrees is equal to 61.7 divided by y. Therefore, y is equal to 61.7 divided by tangent 18.1. If you were to do that on your calculator, you find that distance is 188.8. Okay. Well, now we can compute the value of x off of this top triangle. So let's do that here. I'm not going to redraw the triangle. We'll just take this as the opposite. This is the adjacent. I could say the tangent 48.3 degrees equals opposite x over adjacent 188.8. So x is equal to 188.8 times the tangent 48.3 degrees. And I get the x to be 211.9. Okay, at this point we're ready to finish this by finding the height of the building that we want. The height is 211.9 plus 61.7. The height we're after is 273.6 meters. This next problem asks us to evaluate the composition of trig functions where one of the functions, this time the inner function, is an inverse trig function, the arc sine. So I'm going to begin just right inside of here. Let's just deal with that. Arc sine square root of 3 over 2. Arc sine square root of 3 over 2 is equal to some angle theta. This expression here is equivalent to sine of theta equals square root of 3 over 2. So I kind of asked myself, at what angles at what angles does sine have a value of square root of 3 over 2? Okay, so let's think about our unit circle. Sine is the y-coordinate of the point on the unit circle. So that would have a value right here, which is at pi over 3. Would also happen right here, which would be at 2 pi over 3. Okay. Now we do have to remember that inverse sine, arc sine, has domain pi over 2, actually negative pi over 2 to pi over 2. So we only want angles that are here on the right side. So the 2 pi over 3 gets thrown out, and we just want pi over 3. Okay, so pi over 3 is this angle theta, which is the answer to what we see inside of here. Now the question becomes, now let's look at this outer piece. We want the tangent of pi over 3. Tangent of pi over 3, we need the full point. Okay, so this point right here is 1/2 square root of 3 over 2, and for the tangent we're going to divide the y over the x, which is square root of 3. Okay, state the viewing window of the graph of the function, let's write it right here, -2 cosine x over 2, shown below using what we know about transformations, or specifically what we know about amplitude and period. The amplitude of this function is 2. Okay, it comes from that number right there. The period of this function is 2 pi divided by 1/2, which is 4 pi. Okay, so let's apply those to this graph. Let's do the amp first. The amplitude is 2. That means that this line right here at the peak of this graph is 2, and right down here is -2, which would mean that this mark is 1, and if we count it up, that's 4. We see the same thing on the bottom, that's -4. So my viewing window, my y values, let's just write it over here, are -4 to 4. And now I need the x values to go with that. Okay, so let's talk about the x. And to consider the x, we need to consider the period. Okay, period is 4 pi, so from this, I'll just kind of squiggle it in here so we can see it. Right there. That's 4 pi. After we hit this mark at the bottom, we just see the same exact thing again, which means that's another 4 pi. So that's a total of 8 pi. Now we see this image right here just one time to the left, which makes that -4 pi. So the x-axis viewing window is -4 pi to 8 pi. Next I want to look at another composition of functions, just like we did 2 problems ago, except this time we've got an algebraic expression for x, or algebraic expression of x for this arctan here. Okay, well, I'll start it kind of the same way. What this means is that there is some angle theta that's equal to the arctan of 4x, which means that the tangent of that angle is equal to 4x. And I use this to build a triangle. Okay, tangent is the opposite side divided by the adjacent side. So the opposite is 4x. The adjacent is 1, as we can consider this 4x over 1. And now we need to use Pythagorean's theorem to find the third side. Pythagorean's theorem here would be square root of 4x squared plus 1 squared, which gives us 16x squared plus 1. Alright, now we're ready to evaluate this outer function. I want cosine of angle theta. Angle theta is what this is equal to, and angle theta is this angle theta right down here on the triangle. So cosine is adjacent over hypotenuse, so 1 divided by square root of 16x squared plus 1. Okay. No need to. Last problem I want to go over, it says the graph below shows a sine wave graphed on the interval negative 3 pi to 3 pi. So I'm going to go ahead and put that on there. Negative 3 pi on the end, 3 pi on this end, and negative 2 to 2. State the amplitude and period of the function. Now it has to find the function, just what's the amp, what's the period. Okay, so the amplitude first. Well, the amplitude is the height of the sine wave. And if this is 2, I can safely assume that this here is 1, and it does appear that that's right in between 1 and 2. So I would say that this graph has an amplitude of 3/2 or 1.5. Now, period. Well, so let's kind of trace this out. If I were to start right here, comes up, comes all the way down, and back up right there. This is 1 period. And we just saw 1 period. Now, if I do it again, we change colors here for emphasis. If I do it again, to there, there's 1 period. And if we do it one more time, we see there's one more of these to there. There's 1 period. And so the graph from 0 to 3 pi shows 3 periods. So therefore the period of this function, if I were to take 3 pi divided by 3, the period is pi. Let's just go one step further, just in case on the test you are asked this. What would this function be? If it's a sine function, it would be 3/2 sine of, to get a period of pi, we would have had to have 2x. Because recall, the period is found by doing 2 pi divided by that number. So there would be our function if asked to find it off of just the graph.